Good morning everyone. In the last class we have studied about some basic stereochemical principles and terminologies like this. We have completed up to chirality. Now today's class we are going to continue from this one. Start with enantiomers. What are enantiomers? Enantiomers is nothing but optical isomers. What is the definition? Enantiomers are the pair of molecules or pair of compounds which having non-superimposable mirror images of each other, then it is said to be an enantiomers. I will give you one example. 2-bromo butane and butane 2-butanol or 2-bromo butane. I'll give you two examples. It will write as 2-bromo, it will be like CH3. One of the example is 2-bromobutane. This is a dextrorotatory compound represented by a sign plus or D. The name of the compound is plus or D 2-bromobutane. This one is represented by negative symbol or L 2-bromobutane. Right. Next one, butane 2-ol. It can be written like this. Yes. These are the two examples we have seen here. This is the dextrorotatory compound and this one is levorotatory compound. These two are togetherly called as enantiomers. Those compounds which are non-superimposable mirror images of each other. If you consider this an object, that will be a mirror image. If you put this object on its mirror image, definitely they will not coincide each other because the configuration is going to change. The spatial arrangement of the atoms and group of atoms will going to change. That's why they will not coincide. When they will not coincide, then it is said to be non-superimposable mirror images. Those compounds having non-superimposable mirror images, then it is said to be enantiomers. Simple definition it is. Enantiomers are the pair of molecules which having non-superimposable mirror images of each other. And this one also, one of the example for enantiomer, that is D-butane 2-ol, L-butane 2-ol. One compound represents dextrorotatory, means that compound rotates the PPL towards right side, and another represents levorotatory, that compound rotates the PPL towards left side. Both the compounds are togetherly called as pair of compounds are called enantiomers. I hope you can understand. These are the enantiomers. Now let us move on to the one more condition is there. Enantiomers are having same molecular formula and same structural formula, but differ is the rotation of plane of polarizer right. That's it. One compound means dextro rotate the right side, another compound rotate the left side. But these two compounds having same melting point, same boiling point, and refractive index, and like etc. Most of the physical properties of the enantiomers are same except one property, that is rotation of PPL. The rotation of PPL light is different for both dextro and levorotatory compounds. Next, let us move on to the next one, that is racemic mixture. What is racemic mixture? The equimolar mixture of enantiomers are called as racemic mixture. Means the 50% of dextro compound and 50% of levo compound are mixed together and obtained as a racemic mixture. In racemic mixture, 50% dextrorotatory compound and 50% levorotatory compound. This is called racemic mixture. Equimolar mixture of enantiomers means dextro and levo called as racemic mixture. And one more condition is there, very important. Why racemic mixtures are optically active or inactive? Definitely racemic mixtures are optically inactive. Why? Enantiomers are optically active. Why? Because they can rotate the plane of polarizing light, that is right side or left side. Dextro and levo both are optically active compounds. When those two compounds are combined together in an equal proportion, then it is said to be racemic mixture. But racemic mixture is not optically active. Why? Because the optical rotation obtained by the dextrorotatory compound is cancelled out by the optical rotation obtained by levorotatory. Right? I hope you can understand. The optical rotation obtained by the dextrorotatory compound can be cancelled out by the optical rotation obtained by levorotatory. So that's why racemic mixture is optically inactive compound. So that is racemic mixture. And next, what is racemization? Racemization means it is a process of conversion of enantiomers into racemic mixture. That process is called racemization. Let us move on to the next one, that is retention and inversion. Let us move on to the next one, that is retention. Retention means it is a type of configuration, and inversion, I'll tell you both the definitions in a single concept. Let us consider one molecule, right? Like A. It's a type of molecule. Here the chiral carbon is there. Chiral carbon means what? The carbon which is attached to 4 different types of atoms or different atoms or group of atoms. And this is the stereogenic center or chiral carbon. And this is one of the organic molecule. Suppose this molecule will go into nucleophilic substitution reaction like Y, right? Yes. We consider X. This Y will going to replace this X, means nucleophilic substitution reaction will take place. Then the product will apply as right C A right. That is a product. Here you can see here the configuration of the product will be changed when the reaction is completed, right? If you look these two images, two diagrams, that molecule is exactly look like a mirror image of this object, this molecule, right? You can see X is near to X. That means what? It is exactly, that molecule is exactly be the mirror images of this object. Means what? The configuration is changed. Configuration means the spatial arrangement of the atoms or group of atoms is going to change when the reaction completed. You can see and you can compare both the molecules. and that is called inversion. Inversion is nothing but the change in configuration of the product when compared to reactant during the chemical reaction. Let us come to this retention. The same molecule will go into the same nucleophilic substitution reaction, but here you can observe this molecule. This is why we are going to replace X. This is C, right? You can observe these two molecules. The configuration will not change during this reaction. Why we are going to replace the X? Right. The A will be in the same position. C and D will also be in their position. That means it is not a mirror image of that molecule. Means what? The spatial arrangement will not change during this reaction. That is called retention. Retention is nothing but the preservation of the spatial arrangement of the bonds and atoms around the stereogenic center. That is called retention configuration. What about inversion? Inversion means the change in spatial arrangement of the bonds and atoms of molecules around the stereogenic center. The configuration is going to be changed. Simple. Retention, there is no change in configuration during the reaction. Suppose when the same molecule will undergo another substitution reaction, that is, suppose I call this product is, this molecule is A and this molecule is B, the product name. Suppose the third possibility is there. This molecule will undergo some kind of substitution reaction. There is a possibility of formation of both the product, like A plus B. If these two compounds are obtained in equimolar proportion, then it is said to be a racemic mixture. Then it is said to be racemic mixture. 50% inversion and 50% retention configuration will be there. Then it is said to be a racemic mixture, and this is the concept. Now let us move on to the very important concept that is very important for your examination also, that is nucleophilic substitution reactions. We are going to study that reactions along with their mechanisms. Yes, let us move on to the next very important concept. They may ask a question for 3 marks about this mechanism, that is SN2 mechanism. SN2 represents nucleophilic substitution bimolecular mechanism. This mechanism involves hydrolysis of methyl chloride. Hydrolysis of methyl chloride. When methyl chloride is heated with aqueous potassium hydroxide, which leads to the product that is methyl alpha and HCl. Right. This is the one of the nucleophilic substitution reaction. Here, the nucleophile OH minus is going to attack this methyl group, will give methanol. This is a simple reaction. Now, I am going to explain this reaction in detail. In addition to these stereochemical aspects, that is called mechanism. Let's see the mechanism. This reaction involves only one step, single step reaction. This is a single step reaction. Consider that molecule this is a methyl chloride molecule. This methyl chloride molecule is attacked by a nucleophile, that is OH minus. This OH minus is obtained by the dissociation of KOH molecule. This OH minus ion acts as a nucleophile, is going to attack on the carbon atom of the alkyl halide from the direction opposite to the halogen present, means chlorine present. This OH minus attack the carbon atom of methyl chloride from the direction opposite to the chlorine atom to form a COH bond. Here, this is the slow step. The formation of COH and at the same time the cleavage of CCl bond will also take place, right? The formation of COH bond and the cleavage of CCl bond will take place simultaneously, and that state is called as transition state. This is called what? Transition state. This state is very unstable and leads to the formation of product. Finally, the CCl bond is going to break, cleavage of CCl bond takes place. At the same time, COH bond will form, that gives the product, that is a methyl alcohol, or simply we call it as methanol. Right. This is the mechanism. In this mechanism, it's a single step reaction, and this step is the rate determining step. The slow step is the always rate determining step, and that rate determining step involves both nucleophile and alkyl halide. That's why the rate of this reaction depends on two molecules. One is nucleophile and another is alkyl halide. So that's why it is called bimolecular nucleophilic substitution reaction. Why it is called SN2 reaction? 2 represent bimolecular, means the rate of this reaction, speed of this reaction with respect to time is depend on two molecules, that is, one is nucleophile and another one is alkyl halide. So that's why we can represent the rate of this reaction is directly proportional to the concentration of both nucleophile and alkyl halide. Right? Alkyl halide represents methyl chloride. And the rate equals to is the rate constant K into OH minus alkyl halide. So what will be the order? We have studied in chemical kinetics about order, right? What is the order of this reaction? Suppose that the rate depends on two concentration terms, definitely the order will be the sum of the powers of the concentration terms. Order is 2. Then it is said to be, this reaction is second order reaction and also called as bimolecular nucleophilic substitution reaction. Simply we call it as SN2 mechanism or SN2 reaction. Is very important. Right.